1 degree is equal to 1 hour, and 1 hour has 60 minutes, which makes sense, and each minute has 60 seconds. So therefore, when we're doing this conversion, 1 minute we denote as 1 with a little apostrophe is equal to, if I convert minutes into degrees, 1 minute, you guys agree, is 1/60th of an hour? Does that make sense? So that means that 1 minute is 1/60th of a degree. 1 second, therefore, is denoted by 1 double prime with 2 apostrophes. So then if 1 second is 1/60th of a minute. So then to figure out what that is in degrees, we would multiply these fractions. So 1 second is 1/60th of 1/60th, which is what? What's 60 times 60? 3,600? So in order to convert a measure into degrees, minutes, seconds, you do degrees plus the number of minutes divided by 60 plus the number of seconds divided by 3,600. Thank you. And then your chapter 2 test obviously isn't until a long ways away. There's questions when I give you guys your worksheet and study guide for this test. There's questions about this. Just make sure you guys know where to find this in your notes. Okay. All right, so let's do a couple problems. So convert 50 degrees, 6 minutes, and 21 seconds to decimal degrees. Round to the nearest 4 decimal places. All right, so the first number obviously is the number of degrees we have. This represents the number of minutes. This represents the number of seconds. So to convert it to decimal degrees, we're going to use this formula, okay? So this equals 50 degrees plus the conversion to convert this to decimal degrees is the fact that 6 minutes, you take the number of minutes and divide by how many minutes there are in an hour. So it's going to be 6 over 60. And this is your minutes. Plus 21 seconds divided by, there are 3,600 seconds in 1 hour. And then you literally just throw that into your calculator. That's it. And to 4 places, anybody? Abel, where's your calculator? Where's your calculator? Uh-huh. Where's your calculator? Huh? Oh. She has a test today. We love logs. 50.1058. And then this is our degrees. Okay, and what I was trying to tell you guys yesterday is this is like an old school thing that they use in the Navy, like to navigate. Unless you guys are on a ship or something, you guys probably will never use this, but just a cool little tool that we can use. All right, so this was our answer, right? We're gonna go backwards now. What if I give you the number? I want you guys to tell me how many minutes there are and how many seconds there are. So we're gonna break the next value apart. Okay, so how do you do that? So part B, we're gonna convert 21.256 degrees into degrees, minutes, seconds, DMS. Round to the nearest second. Okay. You guys ready? The number before the decimal tells you how many degrees to start with. So we have 21 degrees plus something else. So first thing you want to do is break it up. So it's going to be 21 degrees plus the rest of the decimal that comes after the decimal place. Okay, so the first thing you're going to do is you want to try to figure out how many minutes this represents. Okay, so do you guys agree that this is a little bit over 1/4 because 0.25 is a quarter? How many minutes are in a quarter of an hour? 15, right? So whatever this is, it should be a little bit bigger than 15. So how many minutes are there in 1 hour? 60. So the first thing you're gonna do is take this number and multiply it by 60. So the 21 stays as 21 for now, plus this part of the answer times 60 minutes. So this equals 21 degrees plus, what is that number times 60? 15.36, so it's gonna be 15.36, okay? So the way that we represent this is 21 degrees plus, now that we have another number before the decimal place, this represents the number of minutes, okay? This represents the number of what then? Seconds. This is the number of seconds, so how many seconds are there in 1 minute? 60. So take this part and also multiply by 60. So this equals 21 degrees plus 15 minutes plus the remainder of the decimal times 60 seconds. Okay, so if I do that, I get 21 degrees, 15 minutes, and then round this to the nearest whole number. Actually, it might be a nice number. Is it a nice number? What is it? Oh, 21.6. So what is that to the nearest whole number? 22. So 21 degrees, 15 minutes, 22 seconds. And I should put approximately because we're rounding. I know that's a weird idea. When I learned this in trig when I was in high school, I remember it being hard. I don't know why I could not remember the formula. So if you have questions about these ones, just let me know. All right, we're almost done. So this should be review from Math 3. So hopefully we agree that we like measuring in degrees more than radians, right? Because degrees is easier to think about quickly than radians, because radians you almost have to convert it in your head. The second way, more familiar way to measure angles is in degrees. One full revolution around the circle, guys, it was how many degrees? 360. One half of a revolution is 180 degrees. 1/4 of a revolution is 90 degrees, and so on. Since 360 degrees is equal to how many radians was a full circle? 2 pi. Then 180 degrees, half of that is just pi. Okay? So knowing that helps us to be able to convert back and forth between radians and degrees. So 1 degree is the same thing as pi divided by 180 degrees. And 1 radian is the same thing as 180 degrees divided by pi. So to convert from degrees to radians, the way I think about it is, what does a radian measure usually have that this doesn't? And the answer. What? It's a fraction, but what special number does a radian measure usually have? Pi. So if you want pi, I know a lot of you guys are taking chemistry right now, or you guys have taken chemistry before. I think about this like as a unit conversion. You're converting one to the other. Okay, so if I want pi, that means I want pi on top, and I don't want degrees anymore, so I put the degrees on the bottom. So that means I'm gonna put 180 degrees on the bottom. Okay, if I don't want radians and I want degrees, that means I want to make the pi go away. So the pi goes on the bottom, so it cancels, and the 180 degrees goes on top. All right, I'm looking at my notes from last year, and we did 5 examples of this. Do you guys remember doing this last year? Okay, I'm just gonna do like 3, because that's a little overkill. So I'm going to use the conversion where the degrees is on the bottom, so that way the degrees cancel. So I'm going to multiply by pi over 180. Okay, if you guys don't remember how to do this in your calculator, literally put 150 divided by 180 into your calculator, and then do math to fraction. And if you guys do that, which fraction do you guys get? 5 over 6, okay? What am I missing in my answer, though? A pi, right? Where does a pi go, top or bottom? Top. So the answer is 5 over 6, but the reason why we don't put this into our calculator is this is an ugly number, right? If I put that in my calculator, it's gonna give me a horrible answer. So 150 over 180 gives me 5/6. Don't forget the pi is on top. So this is my answer. So same idea, multiply by pi over 180. I forgot my degrees. What the heck? So can someone please tell me what this simplifies to? Good. Negative 13 over 6. So my answer is going to be negative 13 pi over 6. Okay. I want to do one more, one that's weird. So if I do this conversion, what happens when I put that into my calculator? It doesn't simplify. Okay, so this is the only time you guys do this. If it does not simplify, what I want you guys to do is actually put the entire thing into your calculator and round. Okay? And what do we get? To 3 places. Yes, 1.868. Now, when there's a pi, you don't have to write the word radians. Since there's no pi in our answer, please write radians afterwards. Okay. So now let's go the other way. Any questions on this problem? No? All right, let's go the other way. All right. So by converting this to degrees, do I want pi in my answer? So where does it go? On the bottom, good. So it cancels, good. So multiply by, put the pi on the bottom. Pi is the same thing as 180 degrees. So the pi's cancel. How many are guys? 4 times 180 is 720 divided by 3, 240. And I should put equals, not approximately. Equals. All right, B. So same idea, multiply by 180 over pi. Pi's cancel. Oh boy, what is that? 90 times negative 11, negative 990? Okay. Cool. All right, let's do a weird one. Okay, so just because it doesn't have a pi, that's okay. if I want to convert it to degrees, I'm going to take the same value and multiply it by 180 over pi. So this is the same thing as 3 over 1. 3 times 180 degrees is 540 degrees. 1 times pi is just pi. And what do you guys get? Julissa, what'd you get? Yeah, 171.9 degrees. Good. Now, without kind of making it too crazy, why does this answer make sense? What special number have we been talking about? We talked about pi, right? What is pi as a decimal? About what? 3.14, right? So isn't 3.14 pi, isn't that half the circle? How many degrees is half the circle? 180. Isn't this number a little bit less than pi? So shouldn't this value be a little bit less than 180? So that makes sense. Okay. All right, last thing. Arc length. Well, almost last thing. We have arc length and then area of a sector. For a circle with radius r, the length s of the arc that intercepts a central angle theta of a circle is s is equal to r theta, where theta is in radians. All right. So a couple problems using this. Find the length of the arc of a circle with a radius of 2 meters subtended by the central angle theta which is 0.25 radians. All right, so what the heck does this mean? So visually what this means is we have some circle with a radius r, okay? And then remember, it doesn't matter where I draw the radius. It's always the same distance. So if this is r, then I could call this r also. We have some angle theta. And then what we're learning about is that this arc is equal to and measure the same number of degrees and same number of radians as whatever this angle is. So this arc right here is S. So if I want to find the length of the arc, that means I'm finding S. So in the box you guys just copy down, you guys have a formula that says that the arc S is equal to the radius times theta. So the radius I gave you guys was what? 2. And theta, 0.25. 2 times a quarter is 0.5. Since this is a length of an arc, we need to include the units. So this is 0.5 meters. Find the measure of the central angle with an arc length of 9 miles and radius of 10 miles. So from my formula, guys, which variable are we solving for if we're trying to figure out the angle? Theta. So S is equal to R theta. What does S stand for? The arc length. What's the measure of the arc length? 9. So 9 is equal to the radius, which is 10 theta. So to solve for theta, divide both sides by 10. And we get theta is equal to 0.9. Theta is measured in radians in this case. Good. Okay. Last problem. I know this section's long. Last problem. So when you guys hear the word sector, I want you guys to think like slice. We all love pizza, so if you think about this like a pizza. The area of a sector is like the area of one slice of this pie, okay? So the area of a sector of a circle is formed by a central angle theta, so I'll tell you the measure, and then I'll tell you the radius, and then that way we can figure out the area, okay? The one thing you have to pay attention to is that the angle has to be in radians to use this formula. So the area formula for this is area is equal to 1/2 r squared theta. All right, so as soon as you guys have that ready, go ahead and copy this down. Okay. So to do these problems, you don't need a picture per se, but I'm going to draw a picture for you guys so you guys understand what it's asking. So here's my center of my circle. I have my radius. How long is the radius according to the directions? 6 feet. So this is going to be 6 feet. This is going to be 6 feet. Okay. My central angle, they tell us, is 120 degrees. So we want to find the area of the sector. So the area of this slice of the circle. So trying to find this area right here. All right, so something should jump out at you guys, though, from this problem. What does our definition say we have to have in order to use this formula? What does the angle need to be measured in radians? Is it in radians right now? But don't we have a formula to convert it? We do. So the first thing you have to do, which is kind of annoying, is you have to change this to radians first. Okay? So convert 120 degrees to radians. So if I want it in radians, that means the degrees goes on the bottom, so it cancels, and pi goes on top. So if I multiply and simplify, you should get 2 pi over 3. So this becomes theta. So to use my formula, area is equal to 1/2 r squared theta. So 1/2 times my radius, which was 6, times my angle, which is 2 pi over 3. And if I throw all that into my calculator and round to 2 places, I'm looking at my answer from last year and it's only 1 place. Can you guys check for me what you guys get? Oh, 6.9? 6.9 something? 9.9? Okay. So to 2 places, it's pretty close to 37.7 then? Right? Right? Okay. It's okay. Feet. Now, because it's area, guys, do I leave it as feet? Feet squared. Good. All right.